like to welcome everyone to the fourth Ellie Talk, specifically on the topic of recycling textile waste streams, which is of course a topic of the day, and in light of the circular economy and the challenges, very, very actual for our textile and fashion industry. Just as a brief introduction, Ariadne Innovation is a startup company that has created Ellie as an ambassador, a digital ambassador, a physical ambassador for sustainable textiles and fashion. We as a company and as a network, we really believe in the strength of cooperation to really drive this sustainable change in our beautiful industry, not only in Belgium, but of course in Europe as a whole as well. We have created with Ariadne two main products. The first product is our Ellie.Connect B2B ecosystem, where you can connect with players all around the supply chain, value chain, designers, to really find relevant market insights, inspiration, information, and start new products with partners around sustainable textiles. We also have a physical Ellie boutique, where we use a physical booth to really market products in a sustainable, but also in a digital virtual way, the modern way of working, where you can also collect customer feedback. So just as a brief introduction, what we really want to do with Ariadne is inspire the community, inform, and this is why we every month, every 2 weeks, we invite Ellie.Connect experts to really inspire, inform, connect on the topic of sustainable and technology in textiles. So we have our Ellie.Talks Tech and our Ellie.Talks Tex, depending on the topic. So just to give you an overview, we had some talks on traceability, on mechanical recycling, specifically from an industry perspective, on virtual technology. And on 25th of August, we will invite Rosanne van der Meer to talk about fashion on demand. So definitely note it down in your agenda. It's a very interesting story and speaker as well. So I hope you will join as well. But topic today is, of course, circular textiles. Maybe just to briefly also invite you to have a look at our ecosystem. You can go either to our general website, ariadneinnovation.com, or register directly on the Ellie.Connect website, which is on the slide here. And you can start exploring and see what we're doing. You can just register. It's a free option. And of course, we invite you to also join a detailed demo, which is taking place next week, next Friday at 3:30, also via the digital way of working. So just to come back to the order of the day, I would like to introduce and invite Mr. Philippe Colignon, who is a circular economy expert from Centexbel, but also has over 30 years of experience on quality and product safety, which Levi's and CNA. So he's really the right person on the right place today. And he will talk about the Retex Project, the European project on recycling of textile waste streams. So Philippe, I give you the floor, and thank you very much for being here today. We can have a discussion afterwards.
Good.
Philippe.
Thank you, Julie, for the introduction, and good afternoon, everyone. I'm really pleased to participate to this webinar. And there we go. I hope you all can see the presentation. Yes. Is it okay like this? Yep. Okay, so today what I will do, I will cover a series of elements from the Retex project, which has been a long-going project. But maybe before I go into the presentation itself, I would like to briefly introduce Centexbel for those who would not know what we are doing. So obviously we have a strong focus on sustainability with Centexbel, and we do it through a series of activities. There's a very strong focus in research and development, and that was the case, for example, with this Retex project, but there's lots of other things. We also do a lot of product and material analysis in a network of laboratories. We do some consultancy work, product certification with among other things, the Ecotex, where we do quite a lot. We do some professional training, info sessions, etc. So quite a wide range of services. But today, I'm here to talk about the Retex project. A brief word about Retex as such. So this project started, I think, in 2017. It was a 4-year project. It officially ended in March 2021. But still, now there's prolongation, and as you'll see, I mean, there's also prolongations in the industrial world, not only in terms of presentations like today. What this project was aiming at, it was really looking at the recycling of textile waste streams in different ways. So we were considering the transformation of textile waste streams into prime material for the textile industry by recycling. And that's already important here, that we are really looking at recycling and not downcycling. So it was really the idea that we could go from textile product to textile product, so garment to garment, if it was the case, for example. And what we will see in what I will talk about today is, in some cases, it was really fiber to fiber, like in mechanical, and sometimes it was fibers to pellets, and we'll see why in these pellets, but maybe you can remember this photo when we get there. We also looked at different waste streams, and that's another important element in such a project. So we looked at end-of-life garments, and these were coming from both domestic and industrial end-of-life garments, and we'll see it's really important. And then we also considered industrial waste in different ways. It could come from processing or producing industry. So what I would like to say here, for example, leftovers from fabrics in a weaving mill, or it could also be waste during the manufacturing. And eventually, there were also 3 big categories or 3 channels that we wanted to investigate, but the chemical recycling, there was no intention to go really into the details of a value chain, but only to have a kind of technology watch. So we won't touch this one today, actually. But there was a lot more work being done on thermoplastic recycling. I'll get to this one in a moment, and then also on mechanical recycling with different variations. I won't be able to cover all the path that were followed during the project, obviously, but I can cover the main ones for sure. So in this first part, I would like to cover the thermoplastic textile recycling, and here we are talking about 100% polyester material. So the idea for this part was to transform textile waste into raw material for extrusion via mechanical and thermal processes. These two always go together for this type of recycling. And there was a technical feasibility to go from fiber to fiber with this type of recycling. The yarns that would come out after, well, first fibers and then yarns would be intended for the weaving and the knitting. It was 100% polyester waste material from different sources. It's a meltable material, and that's why we can go through thermoplastic, obviously. And we went from waste to pellets, but also to granulates, and I'll explain why. So meaning that from the granulates, then we could go through the normal process that the virgin polyester would go through with the extrusion of filaments or injection molding in different tests. So how is this process working? So if you consider garments being used for this chain, so you have both mechanical and thermal processes. So you have, in fact, quite a lot of operation related to preparation of the material. So it's really important that you get with a clean and, let's say, a single composition material into your chain. And so the preparation is, for example, in case of garments, we'll see also more details, removing labels and tags. It could be also sorting colors. It can be different things in there. It could be also washing, cleaning. Now, once you have your fabric without hard parts, without this kind of elements, then you can go through the threading, where you try to come to bits and pieces of fabric, not fibers, but just small bits and pieces. From there, you can go through a compacting operation that will lead to the pellets. And the pellets, remember, is a photo that I just showed, this kind of plastic bullets. Then from the pellets, sometimes you have a drying, but in fact, what was found out during the trials that were made is that the pellets were not kind of strong or homogeneous enough to go through the next step, and so they needed to go through the granulation process, so that you end up with kind of harder bits of plastic or polyester in this case. And from this, then we could move to the extrusion into mono or multi-filament filtration. What is important in all these processes, and we'll see it's not specific to thermoplastic, is that you tend to lose properties during the processes, whether it's mechanical or thermo in this case. You lose the properties, meaning that you need to correct that. And how can you correct that? You can correct that for one part by injecting maybe virgin material together with the new, with the recycled one. I don't know, virgin fibers, for example, when you're doing your spinning. But it also means that in some cases, and it's like this here, you need to use additives like viscosity boosters to really get the right stuff into the extrusion, so that you can have a bigger variety and a higher quality for the output. In terms of equipment that was considered, so I will quickly show the three main ways that were followed. So you always started from granulate of 100% recycled content, and then all the tests for extrusion were made in VKC in Kortrijk, the Vlaams Kunststofcentrum, which is also one part of Centexbel actually. And there they made different trials. One was to go from granulates to filament with different recycled content, 25, 50, 75 or 100% even. There was another setup to go to a different type of monofilaments and also tapes. And it's a different line, which is also a semi-industrial line. And eventually there were also even tests with plastic molding. And there yet it's a different machine. Now, this process is not that simple, and it comes obviously with quite a lot of challenges eventually. That can be fixed, but it's something we need to bear in mind, let's say. So first it requires a well-identified type of waste. And this is something that is true actually for all the recycling operations, not only for this mode. For the shredding and compacting, most of the equipment currently is designed for recycling of hard plastics. And actually, this is probably why we find, in fact, a lot of recycled polyester from buttons also into garments. The issue here, for example, is that the equipment is made for hard plastic that moves down through the weight, whereas the fluff is going everywhere in the machine and is really providing quite some issues. So that's something that's a room for improvement in this case. The mechanical and thermal processes, what I just said, is leading to a degradation of the properties that you need to counter one way or the other. The low viscosity is leading to reduced processability, which means that you need also there to adjust all your operations. There are also some real physical issues like high brittleness in the final filament. Related to that, the tensile strength and elongation that were not ideal. There's possibly the presence of impurities. And there again, we go back, if you like, to the type of waste that you're getting into your process. So you can have spinning oils, you can have all types of additives, dye stuffs, etc. Color change due to sublimation, for example, is another problem, because the color that you get into the machine is not necessarily the one that you will get out of it, because there's no dyeing in this process that we considered. And the upgrade of the properties, for example, with viscosity booster or with other add-ons, is leading to a cost, and that's something also that needs to be taken into consideration. So that's for the thermo mechanical and thermo recycling for the 100% polyester. Now, another important exercise was the mechanical recycling, which obviously is quite simpler in terms of handling, but it also comes with a series of challenges. But here, I think we end up with quite interesting conclusions. In this case, for the biggest part, I will cover the polyester cotton first. For this part, in fact, they looked at different possibilities. One of the possibilities was to use end-of-life garments, for example, from the containers where we collect a mix of garments. The difficulty there is really the homogeneity, all the work that you need to do to clean the garments, to get them prepared. And so eventually this was not looked at really in details as one strong possibility. Eventually, the value chain that was identified as having a high potential of success was one that involved garments, professional garments, apparel used in hospitals, and there you have a kind of loop already where an industrial laundry is providing these garments to a hospital, taking care of all the maintenance of these garments. And so you know exactly what's in these garments. And so if you get these garments into a recycling plan, then you know that it's all the same garments with the same content, and there you have let's say you're already on the right side to get your process started. And so in this set of tests, there were several companies involved. Van Moer to make the professional apparel, Minot, who is really a specialist in preparation for recycling in France, and then Textile, who was spinning the yarn and making the fabric, weaving the fabric. So in terms of mechanical recycling, what we are looking at, so for this specific test, they collected 2 tons of end-of-life jackets. So here we are really industrial scale already. This was not a small test. And we are talking about jackets and trousers that came into the process through an industrial laundry. First step, as every time you work with garments, regardless of the type of recycling you're considering, was the removal of buttons and tags. And here it was done through a social employment company. Obviously, this is for one part for the cost, and let's say that you can also it can also benefit to this type of employment and have a positive, give a positive image to the process as well. So Minot did the unraveling and the shredding of moving to the fibers. Then Textile managed the spinning and weaving and finishing of the fabric, and eventually Van Moer made the new garments that went back into a new circle with the hospital. An interesting point, and really I cannot go into all the details, but interesting point here. So we started with polyester cotton, and eventually we kind of end up with polyester only. In fact, what they found out during all these tests is that the cotton is getting really degraded through the industrial washing, and eventually with the industrial washing and then all the recycling operations, you end up with only 10% of your cotton left instead of 35 in the original content, and the rest becomes kind of dust and fluff that you cannot use for this process. At this stage, I think it's also interesting to look at this process in a slightly different way. The way Retex approached it was first really from, let's say, the technical recycling point of view, but eventually they kind of got into the circular economy mode. And I think it's interesting to look at different kind of small steps or even sometimes details that can make a difference from, let's say, pure recycling to something that you can consider already as a circular economy. And if you can consider it as circular economy, you can also sell it as being a circular product. So they collected the material, and the material was in fact new raw material that was an end-of-life garment. So they're already, in terms of finding your resources, it's a positive point. Then the removal of the buttons and tags. So they realized this was really time-consuming. And so for the next cycle, if you like, they went into eco-conception and they looked at ways to make sure that the buttons would always be in spots where that could easily being reached. And so they knew exactly where to find the buttons the next time, but that was even more important for labels or, for example, RFID badges that they hide inside some different parts of the garments. And now they knew that it would always be at the same position. So their eco-conception for the resources and for the preparation of the manufacturing was already a plus. So then we had the unraveling and the spinning. For the final composition of the yarn, I think it's also important. What I didn't mention so far is that when you are doing recycling, you can hardly end up with 100% recycled from your original waste materials. You need to add different virgin material, or in this case, what they ended up doing was to add other recycled material or yarns coming from recycled industrial waste. They also introduced some recycled polyester from bottle, and eventually the only virgin material that they had to use was the cotton for the reasons that I just explained before. Then we had the weaving and finishing leading to fabric that was managed through regional plants. Then they manufactured the new hospital clothing that went into a new cycle. And so here you have an industrial symbiosis between let's say, the end-of-life garment supplied by the laundry and the recycling process, where it's used as waste material, and you have several elements that can be considered in a circular economy. So very interesting loop. Some key takeout and the good news here also, because we are moving to an industrial value chain existing. So successful value chain for a true circular process. It was a win-win situation through the industrial symbiosis, so where the waste becomes the raw material for the next cycle. Eco-conception and design were used for easier removal of hard parts mainly. The final product, as I explained, was mostly recycled, except for the virgin cotton. They ended up with a positive trend for the cost, and they were for this value chain, and at the time they did it because obviously the cost of virgin raw material could move around 7.5% better than a full virgin material. And the other point is that now Textile is building up the capacity and has created a line which is called Dr. Green, Close the Loop. For those interested, they are organizing a seminar at the end of September, really focusing on this product line, and you have a link there for those who would like to look at what they propose. So important here, it's starting point, a project Retex from Interreg, moving to an actual value chain that is now developing itself to something bigger. And eventually, in terms of different trials that we did, I would also like to cover the 100% cotton trials that were based on industrial waste. So in this case, the approach was somehow a bit similar to what we have seen before. The cotton waste, in fact, came from different sources. It came from leftovers from manufacturing and leftover from knitting production. By Le Maillot was for the knitting production, and Petit Bateau provided leftovers from manufacturing. And eventually Procotex did the preparation. The European Spinning Group, ESG, prepared different types of yarns that eventually were knitted to provide the kind of sweaters that are there. So that was and Centexbel did the different types of testing on this one, well as on others as well. So this is how it worked. Petit Bateau, Le Maillot, as I said, did the collection of waste, Procotex, ESG, and Petit Bateau eventually. Right. For the mechanical recycling of cotton, so here the thing is a bit more difficult, probably for the reasons that I just mentioned, that there tends to be quite some degradation of the cotton, and we are talking about a mechanical process. So this means what you get into the machine won't change, for example, in terms of color. So the existing machinery for cutting, tearing, and unraveling is existing, but now what they found out in the test is that you tend not to necessarily get to a very fine yarn, and so what would be expected from the machine's manufacturer would be an improvement to reduce the kind of aggressivity of the tearing before you get to fibers that can be spinned or spun. The best results is obtained out of unwashed industrial cotton. No big surprise there. Obviously, what you get from containers is difficult to handle because of the mix of colors, because of the mix also in terms of quality of cotton. So it's quite difficult. And what you get from industrial washing tends to be really damaged because they have aggressive washing. If you think about hospital garments, for example, they need to be bleached, they need to be disinfected, etc., etc. And so there the point would be, well, ideally, if we could get industrial laundries reducing a little bit the damage to cotton, that would be a serious improvement in the process. The removal of hard points is always required, and the eco-conception obviously is a must as much as possible, especially when you're talking about loops as those that we looked at for the polyester cotton. The recycling per material type and color requires further automation of the sorting process. That's really a key element. You're talking about mechanical recycling, so if you get a mix of colors at the start, well, you get a mixed color result, and that is really uncertain. So you need to do a good job of sorting. And industrial waste cotton, so it's technically feasible. But then there's also big questions, for example, about other streams like the unsold clothing, where again you have a lot of work to remove the buttons, etc. So interesting exercise also on cotton. Now maybe just getting slightly on the side of Retex. Retex did a big series of studies and tests during 4 years. Now maybe we can think a little bit about the textile recycling in the future. And really, I mean, we won't get into the details. That's not the idea, but it's interesting to think about that. So in terms of context, obviously, there's huge quantities of textile waste that is available through all kinds of streams. And you can see this both as a problem because of the huge quantities or maybe the lack of recycling processes. And you can also see it as an opportunity because the waste is there. So waste streams availability and quality is key. In all these processes, even for the thermoplastic, for example, you really need to know what you're putting into the machines, because if you don't get something as homogeneous and as qualitative as possible from the start, you will end up with a result that is not necessarily consistent or not necessarily qualitative. And so the sorting is really important, or the build-up of chains with partners that can deliver you, for example, industrial waste, which is the the best part of the waste currently. There's the EU textile strategy in preparation. So we don't know yet 100% what they will come up with, but as you see in the next point, there will probably an extended producer's responsibility that is on its way. And so I guess around 2025 or something like that, we might have an obligation to return the garments, which is going to provide a different type of streams for the future altogether. Then increasing demand for recycled fibers, yarns, and fabrics. Obviously, if you look at the fashion retail, there's demand for this, and maybe at some point more demand than offer. Circular economy is on its way, luckily, and it's definitely a source of solutions, but not only, because there will be a lot of technology involved in the solutions. And the recycling rather than downcycling is also a key element in all of this. So recycling in future, in terms of technology, really briefly, so mechanical recycling is clearly available and might improve further. Thermomechanical recycling is in progress, but not necessarily there yet in terms of industrial scaling up. Probably there could be a breakthrough from the chemical side. We haven't touched this one, but actually that's one that we hear a lot of in different ways. And so there's lots of testing going on now through different companies. There might be different things more or less advanced. If you look at, for example, the transformation to viscose versus purely polymers, but we are more thinking about an industrial scale up around 2023, 2025, depending on what's going on. So here the purpose will really be to get as close as possible to the original material, polymer, monomer, which means that in this case, you would have a bigger flexibility of use because you almost get to the original stuff. It's development in progress with promising results, obviously, and let's see where we end up in terms of industrial scaling up. And now, last but not least, this last bullet point, sorting technology in progress. We are talking, for example, near infrared for the sorting on the base of the fiber content. That will be probably a key in the future. If you can't provide all the developing technologies with the right input, you might end up with a bottleneck at the start of your process. And so sorting technology, I guess, is going to be a serious challenge in the future. So let's see what happens there. In 1 minute, the key takeouts for this presentation. So I would say, bear in mind, recycling is no magic. No easy recycle method available yet. Same material cannot be indefinitely recycled. Didn't mention, but that's kind of obvious. You always go down step by step. The quality of the recycled material depends on the waste stream quality. Big challenge there. In mechanical process, the virgin or better material must be added. In the thermoplastic process, then you need to use some additives. Luckily, circular economy, let's be positive on this one, it can really help. There's opportunities out there for mechanical process, as we've seen, and the future of recycling has a huge potential with several options that will develop up to an industrial scale up. And really the last point is for those who would like to read more details about everything that was done in the Retex, and there you would find also more technical details about the different tests that have been done. You can go to the Do the Retex site. There's also